Hello everyone, in this video we're going to start having a look at how we use files in Python. In this video we're just going to get an introduction into using files, and in some later videos we're going to examine using files a little bit more. So I guess we should probably start out from the beginning in discussing files. So in starting to talk about files, let's start with, well, what is a file? So a file is a named location on a disk to store related information. So when we say file, that's exactly what we're talking about. And like, this seems like it should be like standard information that we all should know at this point, you know, when we are working on an information technology degree, whether it's a networking degree or a programming degree, or really whatever kind of tech-related degree that we're kind of working on. You know, it seems like it should be understood that we kind of have this knowledge of what a file is. But let's make sure that we're all on the same page with what a file is. So when we're talking about a file, we're talking about a named location on a disk, so on physical storage media, where we're storing related information. So we use this file to permanently store data in non-volatile memory, like a hard drive. So if you can remember back to your hardware class, you have volatile memory and you have non-volatile memory. And your hard drive or hard disk, that's non-volatile memory. And you have volatile memory, which is like your RAM. And so, well, why would we want to use files in our Python programs? Well, up until now, really everything we've done relies on volatile memory, relies on RAM to kind of hold data as the program executes. So everything we've executed in our program is kind of saved to the RAM, whether it's in our online IDEs where we're programming, or on our local machines where we have our, idle IDE set up, or whatever. There isn't any sort of persistence there. Once the program stops running, or once we restart our computer, any kind of, thing that might have been stored in memory in relation to any of our programs is gone. Because we're heavily reliant on that volatile memory for this data use. So we kind of lose that data that we might need for the future of our programs. So we rely on these sorts of things for the future use of data for our programs. So the key really for file use in terms of our Python programs is in persistence. So in using a file in Python, what we really see here in the most basic situation is we see kind of a three-step process. So when we want to read from or write to a file, we need to open it first, right? It's kind of like a book in that sort of way. Before you can get information out of a book, or before you can write into your notebook, whatever you want to do in that sort of regard, you have to open it up first. You have to get to the insides. And so that's what we're doing here with our files in Python. We have to open them up before we can read from them or write to them. So first thing we have to do is we have to open them up, and then we can do what we want to do, whether it's read or write or whatever. And then when we're done, we close it up so that the resources that are tied to the file are freed up. But that file is still saved in non-volatile memory, so all that data that is stored inside of that file is still there and can be reopened and reused at any given time. So that's the great part about using the files. So in Python, a file operation takes place in the following order. We open the file. We perform an operation on a file, whether we're reading from or writing to the file. In this video, we're just going to be looking at reading from a file. In a future video, we're going to be looking at writing to a file a little more. And then we close the file. Seems pretty simple, and it more or less is. So in Python, Python has a built-in function called open that we use to open a file. And in just a moment, when we get to our demonstration, we'll see how to utilize this. This is incredibly simple. We're not getting really complex for this very first video. This function returns a file object. So when we open a file, we're not getting the file data out of the file. That's important to realize. And we'll see that when we get into our demonstration. When we open the file, what we're doing is we're creating kind of a file object. So if we want to get the data out of the file, we have to do a little bit more with this file object that we're creating here if we want to be able to get at that data, whether it's to read it or write to it or do whatever. In this video, we're going to be showing one method of reading the data from the file, but in future videos, we're going to be looking at some other methods of reading and writing data. So the function returns a file object. We also call this a handle, as it's used to read or write or modify the file. So it's what we use to handle the file. So we call it a handle. And you see like the basic syntax that I have for it right here. F equals open. And then in parentheses, we have the file name that's in the current directory. So we're using F as kind of our object name. So we can kind of name it whatever we want here. Oftentimes you'll see programmers name their files F in these sorts of situations, just like F for file. And, it kind of helps us make sense of it. But you could take that and make it whatever you want, as long as it fits into kind of our variable naming schema that we previously discussed. So in the first line of sample code here, where we are looking at the open function, that's if the file is in the same directory. So if the file is in the same directory as your program, it's easy to call on that file. All you have to do is call the particular file name of the file that you're working with. If the file is in another directory on your computer, all you have to do is just put the entire path to the file so that your computer knows where to go to find it. And we can specify the mode while we're opening a file. We can use R, W, or A. R for read, W for write, and A for append. So there are others. There are other methods that we can use, but for our purposes right now, we're going to stick to these three. And so I feel like they're pretty self-explanatory as to what we can do with these modes, and you'll see how we can add them into our open method or our open function when we get into our demonstration in just a moment. But read to read the file, write to write to the file, meaning that you can completely change the file, and append, meaning that you're going to add to the currently existing file. So write rewrites the file, append adds to the existing file, so it tacks onto the end. So most of the time, for safety reasons, you might want to use A for append, but there are reasons to use W for write. We'll talk more about those in future videos, as mentioned. And then, as we've said, once you've done your work here, whatever you're going to do to your file, you have to close it. So when we're done with operations to our file, we need to properly close the file. And closing a file will free up the resources that were tied with the file, and it kind of makes sure everything is done and dusted. So we kind of put everything to rest by using the close method. Now there is a little problem with using the close method, and that's if there's an exception that's thrown that causes the program to essentially crash before the file can close, then the file will remain open in memory. So the file essentially opens, and it never got around to this close method, so the file never really closed. But we can try to circumvent this and try to help prevent this by putting our code in a try finally block, which is not something that we've really done. With our try finally block, we can try a bit of code, and if that doesn't really work, it can do another bit of code as a kind of final bit of code. And in that final bit of code, we can close the file to make sure that it's closed and free up all those resources that are tied to that file. And we're going to examine that in our demonstration. So let's jump over to our demonstration now. I'm in my REPL here. I've just kind of done a little bit of setting up here for my REPL. For this example here, we're going to do everything behind the main gate. So we have the main gate here, we have our shebang here, and we have our file here, a file called practice.txt. And if you're using REPL.it, importing a file into REPL.it couldn't be easier. All you really have to do is take the file from your Windows or Mac or Linux pane and just drag it into the pane here, and it will load it into your workspace, and you can reference it just like it's in the same directory. So it makes things relatively simple. So the first thing we'll do is we'll just open up our file here. So we'll zoom right in so that you all can see this just a little bit better. But I'm going to do everything behind my main gate, as I previously mentioned. So we're going to start off by we're going to do this try finally block here. So we're going to start off by putting everything behind a try that we're going to want to start with. And behind this try is where we're going to put our open, and where we're going to put one of our methods of reading the data that's in our file. And then behind our finally part of this block is where we'll put our close. So in here we'll create our object f, and we'll set it equal to our method open, practice.txt in quotes, because that's the name of our file. And since it is in our workspace here, it's like it's in the same root folder as our program. And then outside of that, we put a comma, and we're going to put this in read mode by putting an R in between quotes, just like that. So now we have this file open as F. Now we could go ahead and try to print this. So let's try to print F. And before we run this, let's go ahead and add our finally portion and f.close. Just like that. And so that's going to close our file. So we want to make sure that we put that after everything is done, because we also don't want to prematurely close our file before we need to close it, right? We want to make sure that we're done using it before we close it. So if I press run here, it's going to open my file. It's going to print the results of opening my file in read mode here. And then it's going to close my file. So let's see what happens here. And we see we get this kind of weird looking code here. IO text wrapper name equals practice done. So on and so forth. And that's because, as we mentioned, this opens this as an object. So we have to do a little bit more manipulation to kind of get the data out of it. So if we want to do some more manipulation here, I'm going to remove this printf here. One of the ways that we can get the data from our open file is to use a for loop. So I'm going to use a enhanced for loop. So we're just going to say for line in F. So for every line, and line could be whatever we want it to be here. We could, that's just another variable name that we're adding into our loop that we've created here. We're going to print the line. And so my practice file here is just a nonsense file just full of lorem ipsum or nonsense text. So when we press run now, we should expect to see a whole wall of lorem ipsum. And there it is. That's all the text from my file displayed out into the console. And we can see that there. And we can actually verify that by just clicking on my practice.txt here. That'll put my text file into the active window here. And we can see that it is the lorem ipsum that we expect. So that's our most basic way of opening and reading a file. We can't get really much more basic than that in terms of opening a file. And now that we have this data in here, we can kind of work with that data in the same way that we'd work with data in any other way. But as I've previously mentioned, in future videos, we'll also examine other ways to read and write to these files. So to get us started here, that's all that I have for this video. Thank you for watching.